Hi everyone. Today we're going to take all of those polynomials that you factored yesterday and we're going to use them to multiply and divide. So first off, what is a rational expression? It's a quotient of two polynomials and it's going to look a lot like a fraction. And just like a fraction, we can simplify it, we can multiply it, we can divide it, and eventually we're also going to add and subtract them. But that's actually a little bit more complicated than multiplying and dividing. So below are examples of what a rational expression could look like. X plus 5 over x. X plus 5 is a polynomial, x is a polynomial. X squared plus 7x minus 4. That's a polynomial. X plus 3 is a polynomial. And that last one, 3a to the fourth, b squared, negative 2c to the fifth, d to the negative third. Technically, you could move that d to the negative third into the numerator to make it positive. So then we'd also have another polynomial divided by a polynomial. Now, when we're simplifying the rational expression, it's simplest when the numerator and denominator do not have any common divisors or factors. So if we can factor something out or divide by a common factor, we do want to do that. Now, there are going to be restrictions because this is a fraction and we're not allowed to have 0 in the denominator. So we have to keep that in mind. So since we can't divide by 0, if there's a number that makes the denominator 0, we have to exclude it from the domain. And the original form and the simplest form have to have the same domain. So even if something gets factored out along our steps, we still have to count it as an exception to our domain. We have to exclude it. So we're going to first, by simplifying a rational expression, we're going to start there. Now, regardless of whether we're adding, subtracting, multiplying, dividing, simplifying, we're going to be factoring at least the denominator and the numerator. So we have to factor both the numerator and denominator. If there's anything common to both, we're going to divide those out. And then finally, we're going to simplify. So let's start with a few examples. And you'll notice that the polynomials used today were the examples I wanted you to do for homework. So I'm not going to go through the steps on how to factor these. I'm going to go straight to factored form. And the first number there, x squared plus 7x plus 10, that's one that we actually factored yesterday. And that in factored form is going to be x plus 2 times the quantity x plus 5. And then our x squared minus 3x minus 10, that will be x minus 5 times the quantity x plus 2. Now, looking at the numerator and denominator, they both have an x plus 2 in common. So those can be divided out or factored out. Now, when we do that, that's going to leave us with x plus 5 over x minus 5. This would be our answer in simplest form. But we're also asked to find the restrictions. Now, restrictions are numbers that make the denominator equal to 0. For example, if I replace this x with a 5, 5 minus 5 is 0, I would be divided by 0. So x cannot equal 5. And it also cannot equal negative 2. Because if we put a negative 2 in that second expression there, the x plus 2, that would also create a 0 in the denominator. So these would be our restrictions. X cannot equal 5 or negative 2. And then our x plus 5 over x minus 5 would be our answer in simplest form. Okay, so let's try another one. This one doesn't involve multiplying or having to factor out, but we do have to look at using our exponents. Now remember, when we divide exponents, we're going to subtract those exponents. So when we divide our expressions, so that x cubed, x squared, 3 minus 2 is 1. So we have an x to the first, or just x in the numerator. We have y squared and y cubed. And it's always largest minus smallest, so 3 minus 2 is 1. So we'll end up with a y down here. But we still have this 24 and negative 6 in the front. Now, both of them are divisible by negative 6. So negative 6 divided by negative 6 is 1. 24 divided by negative 6 is negative 4. So now we have negative 4x over y. That would be our simplest form. And we are going to have restrictions here as well, but there's nothing added or subtracted in the denominator. So x cannot be 0 because 0 times anything is 0. And y also cannot equal 0. So those will be our two restrictions here. Next up, we have 12 minus 4x over x squared minus 9. Remember back to yesterday, we rearranged the order in that numerator. So we have negative 4 times the quantity x minus 3. And our denominator is a difference of squares. So I'll have x minus 3 times the quantity x plus 3. Now looking at our numerator and denominator, they have an x minus 3 in common. So those could be factored out. And so now I'm left with a negative 4 in my numerator and x plus 3 in the denominator. So this would be my simplest form. Now we're going to go back to that original problem to find our restrictions. And our restrictions are going to be x cannot equal 3 or negative 3, because either of those would create a 0 in the denominator. So let's move into multiplying. And really multiplying is just going to, increase the numbers of things that we have to factor, because we'll have at least two fractions that we have to multiply together. So both numerators and both denominators would have to be simplified and factored. So first up, we're going to factor just like we did before. Factor the numerator and denominator. Then we're going to multiply the numerators together to create one big fraction or one big rational expression. If there's anything common in the numerator and denominator, we can divide those out, and then we're going to simplify. So if we look at this one, it honestly just looks like we have four different things we have to factor. So it's increasing our workload. It's kind of the bad thing about multiplying, and there's even more work with dividing. Now our first numerator is 2x minus 8. Factor out 2 out of that. So I have 2 times the quantity, x minus 4. My denominator, x squared minus 16, will become x minus 4 times the quantity x plus 4. Now if I'm looking at my second fraction here, second rational expression, x squared plus 5x plus 4 can be factored to be x plus 4 times the quantity x plus 1. And in the denominator, x squared plus 8x plus 16 is x plus 4 times the quantity x plus 4. Now since we're multiplying these together, you can think of this as being one big fraction. So instead of rewriting it for space, I'm just going to create that big fraction bar. Now looking at the numerator and denominator, there's an x plus 4 common to both. There's an x minus 4 common to both. I don't think there's anything else that can be divided out. So now my numerator will include that 2. I also have that x plus 1 over here. And the denominator, I'm left with x plus 4 times x plus 4, which can be written as x plus 4, the quantity squared. And we do have restrictions. Now, when we look for the restrictions, I have to look at all of these denominators. So x cannot equal 4, and it can also not equal negative 4. So this would be our final answer. These would be our restrictions. Now, when we're dividing, it's a lot like dividing fractions. We have to multiply by the reciprocal of the second term. So when we change it from division, we multiply it by the second term, the reciprocal of the second term. It is a lot like what we just did on the previous problem. Now, there is something we have to keep in mind with our restrictions, because if you think about it, we had the two original denominators. So let's say we had something divided. So we have this denominator and this denominator. When we flip that second fraction, I'm just going to put some numbers here. This first one stays the same, but now it's going to be x over b. So when we look for restrictions, we have to look here and here because those were the original denominators. And then we also have this new denominator. So we have to look for 3 locations for those restrictions. A lot of people forget about that when they divide. So if we're going to go ahead and factor that numerator, it'd be x plus 4 times the quantity x plus 1. The denominator becomes x plus 4 times the quantity x minus 3. They were divided by x squared minus 1 is x plus 1, x minus 1. And the 2x squared minus 6x is 2x times the quantity x minus 3. Now, since we're dividing, that means we have to multiply by the reciprocal. So the first fraction doesn't change. That's going to stay the same. X plus 4 times the quantity x plus 1 over x plus 4 x minus 3. But now that second fraction is going to be multiplied by the reciprocal, so I have to flip it. So now 2x times the quantity x minus 3 is in my numerator, and the x plus 1, x minus 1 is in the denominator. So at this point, we can't factor anything out that needs to be factored out. So our x plus 4s, our x minus 3s, and our x plus 1s. So our simplified answer would be 2x over x minus 1. Now let's talk about the restrictions. So for the restrictions, I want to go back to that original problem here. So we have this denominator and this denominator. So then once we flip it, here's the same denominator, but that second denominator is now in the numerator of the second, and we also have to look here. So as far as the restrictions goes, we have to look at all 3 highlighted areas. So x cannot equal, it can't equal 1, it can't equal negative 1, it can't equal 3, it can't equal negative 4, and it can't equal 0 because of that 2x there. So we have several restrictions on this one. Okay, that concludes our lesson for today. I'll be posting a Math Excel assignment to finish up for this section. So you'll want to look at Math Excel and look for the Day 2 assignment. I'll see you tomorrow. Bye.